Hi guys, in this video I'm going to give you a little trick that I was taught back when I first started to learn exact values of trigonometric ratios. It's a way that you can learn the exact values of trigonometric ratios for the common angles of 0, 30, 45, 60 and 90. So I'll get straight to it. First, what you're going to need is you're going to need to draw yourself two triangles, one equilateral triangle and one 45, 45, 90 triangle. Okay, now in the equilateral triangles, hopefully you are aware that each angle is 60 degrees. So what we're going to do, we're going to give our equilateral triangle a side length of 2, and we're going to give our 45, 45, 90 triangle a side length of 1. So that's 1, and that's 1. So on this triangle, on the equilateral, this is going to be 2. What we're also going to do is, this isn't going to be straight, but we're going to cut the equilateral triangle down the middle. So that's supposed to be a right angle, and we have 1 on each side, so the bottom is also 2. Okay. So on this triangle, this angle here is going to be 45 degrees. Great. And using Pythagoras, we know that this side here is going to be the square root of 1 squared plus 1 squared, which is equal to the square root of 2. So we have sides here, we've got square root of 2, 1 and 1. On this triangle, we have to find the height, which we're going to do by, we'll call this h. We know that h is going to be equal to the square root of 2 squared take 1 squared, just using Pythagoras again, which is equal to the square root of 4 take 1 is 3. So instead of writing h there, what I'm going to do, I'll get rid of that and just write the square root of 3. So what we can do is, once we've set up these triangles, if you had a trigonometry test where you're going to have to use exact values, you can just draw quickly these two triangles, as long as you remember that the equilateral triangle has a side length of 2 and the 45, 45, 90 triangle has a side length of 1. Then you'll be able to use Pythagoras to fill in the other sides. So what we can do now is, we know that because we've cut this one here down the middle, we know that this angle here, because the whole thing is going to be 60, sorry, so this one here is going to have to be 30 degrees. Okay, so getting to our exact values. So what we've got, the angles that we normally will need to know for are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So what we're going to do is we're going to try and work out the exact values of all of these. So let's get started. So what I'll do is I'll start with the sine of the angles. So let's start with hopefully you're aware from just your knowledge of the sine graph that the sine of 0 degrees is actually just equal to 0. That's one of the ones that's you're going to have to remember. And the reason for that is, if you can remember a sine graph, it looks a bit like this. So you've got your sine graph and it goes like this. So this is at 0, the sine graph is equal to 0. Okay, so let's go to sine of 30 degrees. Now hopefully you guys are aware that the sine of an angle is equal to the opposite side divided by the hypotenuse. So what we do is we take that information and we go over to our triangles, the 30-degree one is going to come from our equilateral triangle. So here is our 30-degree angle. Now the opposite side is 1, and the hypotenuse is 2. So the sine of 30 is going to be 1 divided by 2, or you can just write 1 over 2. Great. So let's go on to the next one, the sine of 45 degrees. Now again, we know that it's opposite over hypotenuse. And as you probably guess, what we're going to do to get the 45 is we're going to go to the 45-degree angle triangle. We know that sine is the opposite over the hypotenuse. So the opposite side is 1. The hypotenuse is the square root of 2. So the opposite over the hypotenuse is going to be 1 divided by the square root of 2. Great. Which we could rationalize if you felt like it. Which would then equal square root 2 over 2. Some people like to have it in rational form to start with. So, moving on, we can then go to the sine of 60 degrees. And for that, we're going to have to go to our equilateral triangle again. Now we know that the sine is equal to, sorry to be so repetitive, but I think it's good to get into this habit just so you don't make any mistakes. The opposite side is square root 3 to the 60 degrees. The hypotenuse is 2. So opposite over hypotenuse is going to be the square root of 3 divided by 2. Great. And that's already in rational form, which is nice. And then we finally we go to the sine of 90 degrees. Now, that's going to be equal to opposite over hypotenuse, but I don't know if you can remember, but 90 degrees on our sine graph is about here. And that's when 90 degrees is when the sine graph is at a maximum. And so at 90 degrees, the sine of it is equal to 1. Great. So what we can do is I'm going to work through cosine with you. I'll change colour. So we then go, if we remember our cosine graph starts at 1, it goes down and then back up and then ends at 1. So what we can do is we can, hopefully you guys understand or remember that cosine of 0 degrees is just equal to 1. Now, on to the next one, the cosine of 30 degrees. Now, cosine is equal to, instead of opposite over hypotenuse like sine, it's equal to adjacent over hypotenuse. So we find our 30 degrees, that's from the equilateral triangle. Now the adjacent side is square root 3, and the hypotenuse is 2. So we can see that the cosine of the angle 30 is going to be square root 3 over 2. We then can we'll go straight on and go the cosine of 45 degrees. And that's also equal to the adjacent over the hypotenuse. It doesn't change. We go to our 45-degree angle triangle. The adjacent side is 1. The hypotenuse is square root 2. So it's going to be 1 divided by square root 2. And if you notice, we can rationalize this again. You'll notice that the cosine of 45, because these two sides here are the same, the cosine of 45 is equal to the sine of 45 degrees. So that's a cool little relationship that's good to remember. So then what we're going to do is we're going to go the cosine of 60. That's also equal to the adjacent over the hypotenuse. We go to our equilateral triangle. The adjacent is 1. The hypotenuse is 2. So cosine of 60 is equal to 1 over 2. Now, last one on the cos side, cos of 90. Now, if we have a look at our cosine graph, you'll see when cosine is equal to 90, when the angle is equal to 90, the cosine of it is equal to 0. So it's the exact opposite of the sine. It has no value at 90. So cosine of 90 is just equal to 0. Okay. Now, last but not least, we have tan. So the way we can do tan is we know that tan of an angle is equal to the sine of an angle divided by the cosine of the angle. And that's because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, so if you divide them, the hypotenuses cancel and you get opposite over adjacent. So that's pretty cool. So what you can do is once you've figured out what the sines are of all these angles, what the exact value of the cosines are for all of these angles, you can then divide one by the other to get the tangent. So for example, the tangent of 0 degrees is equal to the sine of 0, which is 0, divided by the cosine of 0, which is 1. So that equals 0. We can see the tan of 30 degrees is equal to the sine of 30 degrees, which is 1/2, divided by the cosine of 30 degrees, which is square root 3 on 2. Now, because you can't divide fractions, you must times by the reciprocal. So we have 1 over 2 times by 2 over square root 3. I'm going to assume that that's pretty common knowledge for you guys watching this. The 2's then cancel, and you're left with 1 divided by square root 3. Cool. Now, let's get rid of this. Cool. So, moving on, we've got tan of 45 degrees is equal to the sine of 45, or root 2 over 2, divided by the cosine of 45, which is root 2 over 2. And anything divided by itself is just equal to 1. Okay, so the tan of 60 degrees is equal to the sine of 60 degrees, which is root 3 over 2, divided by the cosine of 60 degrees, which is 1 over 2, which is the same as square root 3 over 2 times by 2 over 1. Again, the 2's cancel, And we are left with just square root 3, because it's square root 3 over 1, so it's just square root 3. And finally, we've got tan of 90 degrees is equal to sine of 90, 1, divided by the cosine of 90, which is 0. And anything divided by 0, it's either infinity, or in this case, we write undefined. So, basically what we do here, this is just an explanation of how you get your exact values of trigonometric ratios for the common angles of 0, 30, 45, 60 and 90 for sine, cosine and the tangent. It's just a good way to, if you struggle to commit just a table to memory, this is a good way just to work out the values from scratch. So I hope that helped, and I'll see you next time.